Hi everyone, my name is Stephen Markle, Product and Applications Manager for Milestone Incorporated, and today we're going to go over making mercury standards for the DMA-80. Before we begin, let's go over what we'll need to start the process. We're going to need a 1000 ppm mercury solution, a 1% hydrochloric acid solution in water, 3 or 4 10 milliliter amber vials, 3 if you're using a dual cell, 4 if you're using a tri-cell. You'll need a 1 ml pipette, a pipette that can accurately get down to 10 microliters. The associated tips for those pipettes, since we're using hydrochloric acid, you're going to need some nitrile gloves, a force place balance, and our Making Mercury Standards Miles Care document to help with the math as we go through the process. So if you have all those things, let's go ahead and begin. First, we'll jump over to our Making Mercury Standards sheet, and you'll see on the top here, there is instructions to prepare the 1% hydrochloric acid solution, which I did before I started the video. From there, we're going to go to step 1 and prepare a 1 ppm solution from 1000 ppm stock. We're going to enter the part per million concentration of our stock solution based on the certificate of analysis, and in my case, it is exactly 1000 ppm. Then we're going to begin by placing a clean amber vial onto the scale and tearing it out. Doesn't need to be exactly 4 mils. The concentration is going to be calculated for us at the end, and the DMA will be able to calibrate with any concentration that you get. You do not have to do the math. You do not have to do the weights exactly. It'll all work out in the end. So now that I have my scale closed, I'm going to record the weight. And we are at 4.0240. From there, I'm going to take my 10 microliter pipettes, give my mercury standard a good shake. And add in 10 microliters of solution. And then I'll come over here and record my weight after that addition. 4.0338. From here, I'm going to go back to my 1 milliliter pipette and dilute this up to 10 grams or 10 milliliters with this solution. And again, you don't need to try to get it to exactly 10 mils. We're going to calculate our exact concentration when we are all done. And I will try to get it close to 10, but again, it is not required. You can go over, you can go under, as long as your math is good on the back end. I'm going to close my scale, record the final weight of solution, 10.0173. And I'm going to go in and cap my vial. We can go and calculate our first concentration for our 1 ppm solution. I'm going to start by subtracting my secondary weight by my first weight. So 4.0338 minus 4.0240 gives us a weight of 0.0098. Now, using this equation below, I have all the necessary numbers. I can go in and calculate the ppm of my concentration. So we're going to take our C1, in this case it's 1000, because we're going straight from a stock standard, multiplied by our concentration, or the amount, the weight of the standard we put in, divided by our total weight of solution. And that's going to give us a concentration of 0.9783 ppm. We'll write that right here. And we have now completed our first standard. Take my bottle, write the concentration on the front here. Our first one is complete. We no longer need our stock solution of mercury. We don't need the 10 milliliter pipette. We're going to work directly with serial dilutions and a 1 ml pipette from here on out. So moving down the sheet to step 2. We're going to start off again by placing a clean amber vial onto the scale and tearing it out. And begin by adding roughly 4 mils of our 1% hydrochloric acid solution. Close the scale door and record our weight. 4.0223. Now from here, we're going to take 1 mil of our 1 ppm solution that we just made previously and add it into that vial. Come back over to my sheet and record that weight. And then again, we're going to take our 1% hydrochloric acid solution and dilute this up to 10 grams. Close my scale door. Record our final weight. And then go in and subtract my weight 2 from my weight 1. So 5.0252 minus 4.0223 gives us 1.0029 grams. From here, the math is the same, except instead of using the stock concentration of 1,000 ppm, we're pulling from this solution here. So our concentration to start with is going to be 0.9783 ppm times a total weight of 1.0029 grams divided by our total solution weight, 10.0265. And that gives us a concentration of 0.09785 ppm. We're going to write that right here. Take my vial, close it up, give it a good shake, and then write out my concentration. We're going to go to our next sheet and go to step 3. Again, a serial dilution of the previous sample we made, standard we made. I'm going to start off by tearing my vial. And adding 4 mils of 1% hydrochloric acid solution. Always make sure to change your pipette tips in between. Close my scale door and record the weight. 4.00105. Then for my previous solution, my 0.09785 ppm, give it a good shake. My scale door and add 1 mil. Close my scale door. Record my weight, 5.0142. And then dilute up to 10 grams with my 1% hydrochloric acid solution. Now, if your concentration is getting a little off, say you over diluted or under diluted the initial sample, here's where you can make some changes to help bring it back in line. Again, you don't have to do that. It's a point of preference. But in this case, just so you know how to do it, since my concentration is a little bit lower than my 0.01 ppm on the stock that I pulled, I'm not going to dilute quite to 10. I'm going to keep it a little bit under. And that is going to change our math on the back end. So in this case, I'm going to go to about 9.9. Close my scale door. Record my final weight, 9.9137. Go in and subtract my second weight from my first, 5.0142 minus 4.0105. Gives me a total weight of 1.0037. Now, stock solution from my previous dilution was 0.09785, so that's what we're going to start with. Times our total weight of 1.0037 divided by the total weight of the solution, 9.9137. And that's going to give me a final concentration of 0.0099 ppm. We'll write that right there. Take my vial out, cap it, give it a good shake, and then write my concentration on the front. Add in roughly 4 mils of 1% hydrochloric acid solution. Again, always remember to change your pipette tips in between. Close that door and record my first weight, 4.0205. I'm then going to take 1 mil from my 0.0099 ppm solution we made in the previous step and add that door, record my weight, 5.0267. And then again, using my 1% hydrochloric acid solution, I'm going to dilute up to about 10 grams. Again, I'm going to go slightly under the 10 gram mark to get my concentration more in line with where I want it. But you can just as easily leave it as is and let the DMA do the calculations for you as you're building your calibration curve. Door. Record my final weight, 9.9569. Subtract my weight 2 from my weight 1, so 5.0267 minus 4.0205 gives me a total weight of 1.0062. Using the concentration from our previous stock solution, 0.0099 times the weight of this sample divided by our total weight, gives us a near perfect solution of 0.001000, which we don't need those. We're only going to 4 decimals. We'll write that over here, 0.001. Cap my vial. Give it a good shake. And write my concentration. We have now made our 4 stock solutions for the tri-cell or 3 for the dual cell. So at this point, we are ready to begin calibration on the DMA. On the dual cell, you'll need your 3 stock solutions. On the tri-cell, you need your 4. And on the next video, I'll take you through the entire software and we'll build a calibration curve real time to get you set up to run Mercury on your system. And if you have any other questions, feel free to email us at applications@milestonesci.com or give us a call anytime. We're happy to help with anything you guys need. And be sure to check out the next video where we're going to use these standards to make a calibration curve on the DMA system itself. Thank you.